Let's get into biomolecules and try and understand Fisher projection formulae for glucose and fructose. Now, when we see the structure, it's obviously aldehyde group there, so known as aldose, and in case of fructose it is a keto group, so known as ketose. In case of glucose, the first carbon has aldehyde group, whereas in case of fructose, the second carbon has keto group. Now, if we check the organization of hydroxy and H group in case of glucose and fructose, what we find is always it is better to, whenever we draw a structure, always it is better to start from base. Now, prior to that, let me talk about numbering of carbon. Now, numbering starts from here 1, 2, 3, 4, 5, 6. As we know, as per IUPAC preference series of functional groups, aldehyde stands much above alcohol group. So numbering starts from here, giving preference to aldehyde. So numbering starts from here. Otherwise, numbering would have started from here. It would have been 1, 2, 3. So it starts from here. So 1, 2, 3, 4, 5, 6. Similarly, in case of fructose also, we have keto group over here, which is more preferred than hydroxy group. So it is given least number by starting from here. So 1, 2, 3, 4 like that. So that's about numbering. Now about placing hydrogen and hydroxides. It's always better to start placing hydroxides from below. What we have got to keep in mind is these two hydroxides are twins. They always stay together. Alright. If these two are this side, if this one is this side, this one also would be this side. If this one is that side, that one would also be that side. Okay. So we have chosen this side. Now this has some configuration which I'll talk about a bit later. OH I have written this side, other OH has to go that side, then alternate this side, and then obviously aldehyde. So two OHs identical on the same side, and then other side, then other side, and aldehyde. Similarly here also in case of fructose, we find that these two OH which are there, this side, OH that side, second one is the keto group, and again we have got CH2OH. So that's how the organization is there. Now we call this as D-glucose. Whenever OH is on this side, we call it as D-glucose. If OH would have been on the other side, on the left hand side, we would have called it as L-glucose. Just for reference, let's check out over here. It's all based on glyceraldehyde structure. Now in case of glyceraldehyde, if you see D-glyceraldehyde, then we find that it has got CHO, CHOH and CH2OH. This is CH2OH, identical to this CH2OH. And the penultimate OH is towards the right hand side. Now since it is towards the right hand side, so we call it as D-glyceraldehyde. Similarly here also we find that this OH is on the right hand side, so we call it as D-glucose. So it's all based on glyceraldehyde. Alright, and basically just condense the molecule, condense all these things. So we have got CHO on the top and CH2OH at the bottom. So we have got CHO at the top and CH2OH at the bottom. And then check out only the penultimate carbon's hydroxide, left or right. Now in this case, since it is on the right, so we call it as D-glucose. And in this case, it was D-glyceraldehyde. So based on glyceraldehyde, we write L or D. So if right now, if this OH would have been on the other side, we would have called it as L-glucose. Obviously, if this OH would have been on the other side, even this OH would have been on the same side. All right. Same thing is about fructose also. Fructose also has OH on this side, so it is D. And if it is on the left-hand side, the penultimate hydroxide, then we call it as L-glyceraldehyde. Now, what I say is the best way to keep in mind is left L. So when OH on left, we call it as L configuration. When it is on, obviously when it is on right, then we have got to call it as D configuration. This is just a small tip to not to get confused between L and D. Alright, that's about L and D. Now we talk about plus and minus. Now plus and minus, I have explained it very well in my earlier videos, where whenever it is minus, we call it as levorotatory, and if it is plus, we call it as dextrorotatory. Now see this L and D, L and D is based on your placement of hydroxide, left or right. Whereas this plus and minus is absolute configuration. It does not depend upon L or D. Like for example, here itself you can see D glucose is positive, that is dextrorotatory. Whereas here we find D is negative. So it's absolute. It depends purely upon polarimeter. Positive and negative are determined by polarimeter. Now assume that this is plane of plane polarized light. And if we place this sample into a polarizer, then what we would find is that the plane of plane polarized light would be shifted by some degree towards left. And if it is shifted towards left, then we assign it as negative, sign-wise, or levorotatory compound, levorotatory chiral compound. Whereas in this case, if we suppose put in this sample in polarimeter, we would find that the plane of plane polarized light would deviate the plane towards right hand side. And when it does so, we call it as dextrorotatory chiral compound or plus chiral compound. Alright, so this is how we represent negative and positive with the help of polarimeter. Alright, now another interesting thing is that in case of this we put in small l, whereas in case of this we put in small d. So whenever we talk about small d, then it is dextrorotatory. And if it is dextrorotatory, means this is dextrorotatory. And whenever we talk about small l, it is levorotatory. It is this. But if we talk about capital L, then it's based on glyceraldehyde. If we talk about capital D, it's again based on glyceraldehyde. So capital DD is purely based on configuration of glyceraldehyde. Whereas these symbols or small l and small d are purely based on polarimeter. Alright. So now again another interesting is this is D as per glyceraldehyde, but positive as per optical rotation. This is D as per glyceraldehyde configuration, but is negative as per optical rotation. Okay, so there's no as rule as such that D has to be, if D is positive, it has to be positive here itself. Both are independent of each other. All right.